Which of the following statements are true? If it is false, correct it. A. All particles in the nucleus are charged. That's false. Neutrons have no charge. Neutrons are not charged. They're neutral. Right. B. The atom is best described as a uniform sphere of matter. Electrons are embedded. That's J.J. Thomson's, or that sounds like J.J. Thomson's plum pudding model. All right, so that's false. Because his student, Ernest Rutherford, if you recall, did that gold foil experiment where he shot alpha particles and most of them hit the detector right on the other side. That showed that, number one. All right, atoms are mostly empty space. This is the gold foil experiment. And some of them bounce back at large angles, and so that also Rutherford just concluded that, number two, there's a dense positive region, and then the atom is surrounded by a mostly empty space, which are, we know that them to be as electrons, electron clouds. So this was disproved by his student Ernest Rutherford. All right, let's go on to C. So far, false and false. The mass of the nucleus is only a very small fraction of the mass of the entire atom. Well, that's like opposite world. That's also false. It's not a small fraction. It's a very large fraction. Almost all of the mass is in the nucleus. All right. So so in terms of atomic mass units, all right, or U, proton is roughly 1 atomic mass unit. All right, neutrons are approximately 1 atomic mass unit, and electrons are about 1,840, almost 2,000 times smaller. So these two things make up the nucleus. So would you say the nucleus is a very small fraction of the atom, which is only comprised of those three things? No, you would say the nucleus has almost all of the mass in an atom. So C is incorrect. D? What haven't I used? Here we go. D. The volume of the nucleus is only a very small fraction. Again, this is, oh, no. The volume is a very, hold on. The volume of the nucleus. This is true. All right, so this is true. Sorry. The volume of the nucleus is a very, very small. The size of the nucleus is very, very small compared to the overall. So if that was the nucleus, then like maybe that's the atom. It's mostly empty space, and so the volume is very, very small, but very, very dense. It's a little bit counterintuitive because many things in our macroscopic world, if it's very dense, it's also very large. Or if it's very, very small, it's very not dense or light. Sometimes you can, in some ways you can say, right? But that's not true for the atom. The nucleus is very dense, very massive, but also takes up very, very little bit of space, which is why it's dense. All right, finally, E, number of neutrons in a neutral atom. All right, so neutrons have nothing to do with charge, because that they're neutral. Neutrons are neutral, right? But that's not why an atom is neutral. An atom is neutral because the number of protons equals the number of electrons. Those are the subatomic particles with charge, right? So you can have as many neutrons or a few neutrons, and that's not what makes it neutral. It's because the balance of the particles that do have charges are equal to each other. So this is false. It's the protons and electrons that determine whether something is neutral or not.